1.7 inequalities. Continuing on with inequalities, now we're going to look at quadratic inequalities. Now, quadratic inequalities are those that can be written in the form ax squared plus bx plus c less than or greater than 0, doesn't matter which way, where a is not equal to 0, because if a was equal to 0, then we'd have a linear inequality. Okay, when we're solving a quadratic inequality, the key is to replace the inequality with an equal sign and then solve. Solve the quadratic to get its solutions, use those solutions to create intervals, and determine on which of those intervals this expression or this inequality will be correct. And then dependent on whether there's a strict inequality or a non-strict inequality, we may have to test the endpoints of the intervals to see if they are valid or not. So let's get started with that, because it's one of those things that's much easier to see as you do it than to understand as you're hearing words. So x squared minus 2x minus 15 less than or equal to 0. So the key is, first, just treat it as an equation. So we're going to solve the equation x squared minus 2x minus 15 equal to 0. Two numbers that multiply to negative 15 and add to negative 2. Signs are opposite, larger numbers negative, negative 5 and positive 3. So x plus 3, x minus 5 equal to 0, x plus 3 equal to 0, so x equal to negative 3, x minus 5 equal to 0, so x equal to 5. So we have these two values. Now we're going to use these two values to create our intervals. So our intervals are going to start at negative infinity and go to the first of these values, which is negative 3, from negative 3 to 5. So these are just going to be the dividing points for our intervals, and from 5 to infinity. So those are our three intervals that we're going to test. All we need to do to test them is plug in one value in that interval and see what we get, whether it ends up being, whether it makes this statement true or not, I should say. Okay, so if we look at negative infinity to negative 3, now you usually try to use the easiest numbers that you can, but we don't want to use the number that is the end of the interval, because that's testing the endpoint, not the actual interval. So let's try negative 4. From negative 3 to 5, can't get much easier than plugging in a 0. And then from 5 to infinity, let's grab 6. So I'm just grabbing what I consider to be the easiest numbers for me to use. So negative 4 squared, I'm just going to switch to a different color so I can write up there. Let's use this orange one. I don't use it much, and it doesn't come out looking orange anyway. So negative 4 squared is 16. Negative 2 times negative 4 gives you plus 8 minus 15. So 16 plus 8 is 24. 24 minus 15 is 9. That is not less than or equal to 0, so therefore, no good. Well, let's try 0. That's pretty easy to test. 0 minus 15, negative 15 is less than 0. So we like that one. And then 6, 36 minus 12 minus 15. 36 minus 12 is 24, minus 15, 9 again. And 9 is not less than or equal to 0, so that is no good. So we have this interval. Now what we need to check is, notice that this, what we're looking for when it's equal to 0 also. So we're going to check -3 and 5 and see whether that they make it equal to 0. So if I take -3, -3 squared is 9. -3 times -2 is positive 6, plus 6. Minus 15, 15 minus 15 is 0. So that one's good. We're going to include that. And what if we do 5? So 5, we got 25 minus 10 minus 15. 25 minus 10 minus 15 gives us 0. So that one is good also. So we have the interval from -3 inclusive to +5 inclusive is the solution set for this quadratic inequality. So the process again, treat it as if it's just an equation, a quadratic equation. Solve for x or solve for the variable. Use those values to create intervals. Test a number in each of those intervals to determine whether it makes this statement true or not. And then if it's not a strict inequality, check the endpoints to make sure whether they make it true or not. If it's a strict inequality, you don't have to deal with the endpoints. They're not going to be included. And I'd be willing to bet that most of the time, if it isn't a strict inequality, if it's less than or equal to, greater than or equal to, that they will be included, but you always need to check. But I can guarantee if it's a strict inequality, if this was just less than, then you would not include the endpoints. Well, let's do another example. Basically, if you can factor a quadratic, or find the solution to a quadratic, then you can find the solution to a quadratic inequality. Three x squared minus 11x minus 4 greater than 0. So we have a quadratic, so we're going to set it equal to 0 instead of greater than 0. So 3x squared minus 11x minus 4 equal to 0. Now this one we have a choice. Do we want to factor by grouping? Do we want to use the quadratic formula? I'm going to be lazy and just use the quadratic formula. And hopefully it'll work out nicely. If not, I'll be glad that I used the quadratic formula. So x is equal to -11 plus or minus the square root of -11 squared minus 4 times 3 times -4 over 2 times 3. Now you got to get where the quadratic formula just kind of comes to you. And it takes a bit of practice. If not, you can always derive the quadratic formula like I did with completing the square and then write it down in your paper. Or if you're doing homeworks and such or in the real world, you could just look it up. Being realistic. Okay, so x is equal to 11 plus or minus the square root of 121 plus 16 times 3 is 48 over 6. So x is equal to 11 plus or minus the square root of 169. That's handy. Over 6. Why do I say that's handy? Because the square root of 169 is 13. So x is equal to 11 plus or minus 13 over 6. Doing this, x is equal to 11 plus 13 is 24. 24 over 6 is 4. And 11 minus 13 is negative 2, giving us negative 2 over 6, or negative 1/3. So now I've got my two values. I can create my intervals. Remember, it's not just checking these two values. We're used to doing that. So, okay, do these work? Now what we're doing is we're using this to create the intervals. So I'm just going to move over here. I'm trying to do it from this side. And we've got 4 and negative 1/3. So negative 1/3 is going to come first. So our intervals are from negative infinity to negative 1/3. From negative 1/3 to 4, and from 4 to infinity. So again, we want to take the easiest values that we can. Just trying to make sure I'm actually in the picture here, right? So what I see here is probably easiest is going to be negative 1. Here it covers 0, that's always easy, and here I'll put 5. So plugging in negative 1, come back over here to do that. I plug in negative 1. Negative 1 squared is 1, so 3 times 1 is 3. Negative 1 times negative 11 gives us positive 11 plus 11 minus 4. 3 plus 11 is 14, minus 4 is 10, which is greater than 0. So that one's good. What about 0? If I plug in 0, 3x squared is 0, minus 0, minus 4. Negative 4 is not greater than 0, so that one's no good. And then 5. 5 squared is 25. 3 times 25 is 75. 5 times negative 11 is negative 55, minus 55, minus 4. 75 minus 55 is 20, minus 4 is 16. 16 is greater than 0. So yes, we're good. Now remember that I said when you are dealing with a strict inequality, then your values that you're using, your boundaries of your intervals, will not be part of it. So you don't even have to bother testing negative 1/3 and 4, because those are going to set this equal to 0, which we need it to be greater than 0. So they're not going to be included. So now we can say from negative infinity to negative 1/3, and from 4 to infinity. So we can have any value from negative infinity to negative 1/3, or any value from 4 to infinity, and that'll make this work. So let's do another word problem with this. Let me erase this off the board first to give us space to work. I'm going to bring in another one of those word problems. And this one's going to be similar to one that we did in a previous video, where we're going to deal with projectile height. So let me just bring this in here. So I'm going to share that. Oops. Oops. Here's where you see Mr. Davis make his little oopses. There we go, projectile height. Sorry, I thought I had moved forward on the slide, and I had not, obviously. So projectile height. If an object is launched from ground level with an initial velocity of 144 feet per second, its height s in feet t seconds after launching is s equal to negative 16 t squared plus 144 t. When will the object be greater than 128 feet above ground level? Now, it's not asking at what point does it surpass 128 feet. It's saying, when will it be above 128 feet? This is going to go up into the air, and it's going to come back down. Well, if 128 feet is somewhere there, we're talking about how long does it stay above there at what time interval? So let's put this information on the board. So initial velocity is 144 feet per second. V sub 0, 144 feet per second. Height is S in feet, so S is height in feet. T is time in seconds. And the equation is S equal to negative 16t squared, so 16t squared plus 144t, and that 16 again comes from the force of gravity. 2 times that is 32. The acceleration due to gravity is 32 feet per second. And the 144 comes from the initial velocity, and our constant term is 0, which is we started at ground level. So if you've taken physics, you may recognize some of these equations from them. We want to know, when will the object be greater than 128 feet above the ground? So we want to know, when is S greater than 128 feet? So that's what we're looking for. So let's zoom in on the board. If I can convince it to do so. Because now, since I clicked on that, it's being finicky and does not want to do that. I'm gonna have to battle with it slightly. There we go. Sorry about that slight delay, because I'd been on the wrong slide and did the previous. It decided it didn't want to let me connect to that. So we have this information. The real thing we want to know is we're looking for S to be greater than 128 feet, which means our equation is, we want this thing, negative 16t squared plus 144t, to be greater than 128. So don't get confused and make it 128 greater than that. This we want to be greater than 128. So we're basically saying negative 16t squared plus 144t greater than 128. So that's our inequality. To solve that, we want to set it equal to, well, we want to put equals in there and turn it into an equality, an equation, and then solve. So we're going to bring 128 over. So I can say negative 16t squared plus 144t minus 128 greater than 0. And then I'll set it equal to 0. Negative 16t squared plus 144t minus 128 equal to 0. And here's where we start looking for what we can do with this. Now, first of all, we may notice that we can do a little bit of factoring here. I just want to see, can I pull 16 out of 144 and 128? I can pull it out of 128. Nice, I can pull it out of 114. So that's beautiful. That means that I can actually factor out negative 16, and it's going to leave me with whole numbers there. So that makes my life a little bit easier. So I can divide everything by negative 16, gives me t squared minus 9t plus 8 equal to 0. Well, that made life a lot easier. Two numbers that multiply to 8 and add to negative 9. Signs must be the same. Signs must be negative, 8 and 1. Or I should say negative 8 and negative 1. So I have t minus 1 and t minus 8 equal to 0. So t equal to 1 and 8 are the solutions to this. We're now going to use that to create our intervals. So from negative infinity to 1, from 1 to 8, and from 8 to infinity. So we created our three intervals. We want to use the easiest values that we can. So 0, 2, and 9. Probably actually would have been easier to use 10, so I'm going to switch that to 10. Just because 10 means just a matter of moving things, the decimal place around. 9, I'd have to do some real calculations. So let's go through and doing the same method that I usually do, grabbing my orange marker here. So if I plug in 0, then I end up with 0 plus 0. So 0 is greater than 128. Nope, that doesn't work. If I plug in 2, then I've got negative 16 times 2 squared is 4. So that's negative 64. 144 times 2 is 288 plus 288. 288 minus 64 gives you 224, which is greater than 128. So that one's good. And then if I use 10, 10 squared is 100, so that's minus 1600. 144 times 10 is 1440. So already I can see 1600 is greater than 1440, so we're going to end up with negative, which means it's not greater than 128. So no, that does not work. We're looking for when it's greater than, it's a strict inequality, so we don't need to check the endpoints. So anywhere from 1 second to 8 seconds, the height will be greater than 128 feet. So the first second of flight, it will be below. And then the last second of flight, it will be below, because it's going to be balanced on either side. So actually plugging in 10 there, as we saw, gave us a negative value, which would mean that if we were at a cliff, that'd be great, because that means it's falling down beyond the cliff. So working through those, and a pretty good example of how to do that. So we're going to call that good for dealing with quadratic inequalities.